Alright, today we're going to talk about 3.1, combining like terms notes. Okay, so in 6th grade we taught you guys how to learn this. We're going to review it. Okay, so first of all, we need to know what the different parts of a term is. Okay, so a variable on this problem would be x. Our variable is a symbol, a letter, it's not a number. So like x, y, z, a, b, any number or any letter, and then any symbol, so like sigma, chi, alpha. Okay, and then the coefficient is the number that is along with the variable, right in front of the variable. So 3, it could be a -3 if there's a negative sign there, so it would be -3. Remember, terms have a sign and a number, okay? So it could be -3, but for this problem we just did 3. Okay, the exponent is the number that it's raised to, so whatever the power that variable is raised to is called the exponent. Okay, one thing I want to talk about is 2. If 2 is just by itself, it is called a constant. So if it's just a number by itself, that is a constant. So a variable is a letter, a coefficient is the number in front of the variable, an exponent is the number that the variable is raised to, while a constant is just a number by itself. Alright, so conditions to be like terms. So you have to have the same variable, same exponent. So if they do not have the same variable and the same exponents, they are not like terms. So starting with number 1, we have 2 and it's times x, and we have 3 and we have x. They both are raised to the first power. They have the same variable, x, and they both have the same exponent. So this is, yes, they are like terms, okay? If there is nothing, if it's not raised to anything, it's understood as it's to the first power, okay? Alright, number 2, we have 2a and b. Those are different variables, so no, because they are different variables, they are not like terms. If they had 2a and 3a, then they would be like terms. Number 3, we have x and we have x. Those are same variables, so check off number 1. But then this is raised to the first power, and this is raised to the second power. So no, they are not like terms. They are not the same, okay? So be careful with that kind of problem. Moving on, so let's go ahead, and this just says identify like terms and then identify like terms. So the terms in this problem are just write them out. So positive 3x, so I'm just going to write 3x, because if it's positive, you don't really need the sign in front of it because it's understood as positive. Positive 4, so just 4. And then negative 7x, and then a negative 6. Okay, if there's a negative in front of it, it goes along with the number. Okay, so then those are my terms. Now to find like terms, they have to have the same variable and same exponent. Constants are always going to be like terms, okay? So 3x, it has an x. Is there anything else that has an x? Negative 7x, and x is raised to the first power on both of them. So my like terms are 3x and negative 7x. Moving on, so then I'm going to go to my next one and circle positive 4. Is there any number that does not have a variable with it, like positive 4, negative 6? So 4 and negative 6 are like terms also. So we have 2 like terms. Okay, moving on. I recommend just going ahead and, so let's go ahead and write our terms. So we have negative 9, 2.5y, negative 0.7y, 1, and last but not least we have 6.4y squared. Okay, so what I recommend is putting boxing. If you have different colors, you could do it that way, but like boxing the different terms to decide which ones are alike, which ones are not. So like terms, so I'm going to put LT for like terms. So negative 9 is my box. It's in blue. Is there any number that does not have a variable? It's just a constant also. Positive 1, so my like terms are negative 9 and 1, comma. Then, moving on, I have a positive 2.5y and a negative 0.7y. I also have a positive 6.4y squared, but it is not a like term to those other two because, yes, the variable is the same, but the y is to the second power, while these two have the y's to the first. So 2.5y and negative 0.7y go together. Okay, and then lastly, we would go to the next term that's not circled or anything, 6.4y squared, but there is no other terms that would be with it, so that does not have any like terms. Okay, so now we're going to talk about simplifying the expression. So if it's like terms, you can combine them, subtract them, add them, whatever operation it says. So first step is you go ahead and box your like terms. So I start on the left and I start, okay, 5a. Is there anything else with an a to the first power? Yeah, negative 2a. So those two are the same. Then I go to my next term. I'm going to put it in a triangle because if I didn't have different colors, I would just do a triangle. And is there any other terms that would go with positive 9? No, so it's by itself. So then I combine my boxes. So 5a, negative 2a, opposite signs we subtract. 5 minus 2 is 3, and a is bigger, so we keep the positive. And then my triangle is by itself, so you just drop that one down. So 3a plus 9 would be my answer to this problem. Okay? Moving on, we go ahead. I have an m. I boxed up an m. Is there anything else with m? Yep, negative 4m. So those two are boxed together. Is there anything else with an m? Nope. Now I'm going to circle my negative 1/6. Is there anything that's just a constant without a variable? Yep, my positive 5/6. We combined our boxes, so negative 4 and positive m. If there's nothing in front of that m, it is understood there is a 1 in front of that m. So negative 4n, positive 1m. Opposite signs we subtract, so I get 4 minus 1, which is 3. Another way of thinking of this, if I have 4m and I take 1 away, that would be 3m. And you keep the negative because 4 is bigger than 1. Then 5/6, negative 1/6, so opposite signs we subtract. 5 minus 1 is 4. We have 4/6, and positive is bigger. 5/6 is bigger than negative 1/6, so we keep the 5/6 and positive. And then let's go ahead and reduce this all the way. 2 goes into 4 and 2 goes into 6, and so this becomes negative 3m plus 2/3. Alright. Now let's keep going on number 5. Okay, so I have 2.3w, and I have a negative 3w that would go together. I have negative 7, positive 8.1. Okay, we combine our like terms. Negative 3, positive 2.3, opposite sides we subtract. So add a period, a decimal, and a 0. Subtract, borrow. And 3 is bigger than 2.3, so we keep the negative, and we keep that w there. Don't forget your variable. That will throw off the whole answer. Opposite signs we subtract, so 8.1 minus 7. Oops, 7, that goes there. Okay, 8.1 minus 7, and you should get 1.1. And 8.1 is bigger, so it's a positive. So my answer is negative 0.7w plus 1.1. Moving on. Okay, so before you can do anything, think of PEMDAS. You have to do please parentheses. You can't do d minus 1. You can't combine or do anything, so you just leave it. Then we do exponents. There are no exponents. Multiplication, division. This is multiplication right here. 7 times d minus 1. So we're going to have to use our distributive property and distribute that 7. So 7 times d is 7d. 7 times a negative 1 is a negative 7. And then we still have that positive 2 because it's not being multiplied. It's just that plus 2. Then we combined our like terms to simplify it more. We have 7d. There's nothing else with a d. Then I have negative 7, positive 2. Those two go together because they do not have a variable. And so I have 7d. Opposite signs we subtract, so I get 5. And then we keep the negative because 7 is bigger than 2. So my answer is 7d minus 5. Moving on. Okay, so first step, distribute. So 2 times 4, okay, so I just dropped that 13g down. And then it's a positive 2 times a positive 4k, so positive 8k. And then positive 2 times a negative g, negative g. Negative times positive is a negative. And then we have 2g. Remember, there's an understood 1 here if there's nothing in front of it. And then we go ahead and combine like terms. So I have 13g, negative 2g, and then I have 8k by itself. Okay, so combining like terms, we get 13g minus 2g. So 13 minus 2 would be 11g. And then you just drop this one down because it doesn't have any like terms. So my answer would be 11g plus 8k. Okay, moving on. Okay, so now we do our multiplication first. So I'm going to multiply here. I get 20 times p is 20p plus 20 times 2, which is 40. And then we take this positive 16 and multiply it through. So positive 16 times a negative 3. Opposite signs we subtract, so that's negative 48. Opposite signs, it's a negative. And then we take that positive 16 times a negative p. That's a 1 in front of there, remember? So 16 negative, that would be a negative. 1 times 16 is 16, and we get that p. Then we go ahead and do our next step, combine like terms. So 20p, anything else with a p? Negative 16p. Then we go positive 40, negative 48. 20p minus 16p is 4p. Then 40 and negative 48, opposite signs we subtract. So 48 minus 40 is 8. And 48 is bigger, so it's a negative. So I have 4p minus 8. Alright, write an expression in simplest form that represents the cost of shampoo in cutting. W, women's hair, and M, men's hair. Okay, so women, so it's $15 for a cut for women, plus shampoo would be 5W also. And then if I'm paying for a man also, I have plus 7M plus 2M. Okay, we don't know how many women or men have came in, but we do know that it's $15 per woman, so 15 times W, and it's $5 for shampoo, so for a woman, so 5W, and then men same way, 7M, 2M, and then to find my total, I have to add it all together. Okay, so let's go ahead and simplify. 15W, 5W, those two should go together, they're like terms. 7M, 2M, like terms. 15W plus 5W is 20W, plus 7M, 2M, 9M. So my answer would be 20W plus 9M for that. Alright, this is 3.1, combining like terms. Thank you.